is gonna be the, your homework, your missing homework assignment from first quarter gonna be at?
At the bottom.
Exactly, so when you guys dig through your lockers, that kind of works that way. You can also think of like if, now here's going back to the geology concept, is if you have like every spring, mud comes running down the Green River, and that mud ends up in the bottom of Flaming Gorge Reservoir. Where is this year's mud gonna end up in that pile of mud in the bottom of the reservoir? Well, if it's mud from this year, where is it gonna be if you were to dig to the bottom of the reservoir?
Outside.
It's gonna be on the top of all the layers of mud. So like 2016's mud has to be on top of 2015's mud. And then 2014's layer of mud under that, and 2013's under that, and 2012 under that. So that's basically the law of superposition. So what did you write down for number 2? Because this is really the big idea here. This is called the law of superposition. How would you define this in your own words? Who thinks they can define this? Big guess. Okay, it has to do usually with layer after layer, but what about layer after layer?
It's an over.
Well, be more specific, where's the over at?
The orders are going from top to bottom.
So which is at the top?
What is at the top? What in the mud?
Well, we want to include age here.
Page 60.
Okay,
Youngest layer to the oldest layer.
which way?
Yeah.
So
Top to
the
bottom.
Top to bottom.
top to bottom, what's gonna be the sequence?
So it's gonna be new, and then like the year before that, or the layer before that, like the oldest.
Good, yeah, I think in your mind, you're explaining it correctly, just kind of waiting for the wording to come out a little clearer. Molly?
The newer the layers, the further away from the core it's gonna be.
Okay, yeah, kind of want to maybe move away from always referring to the core, but you're on the right track. We're definitely talking about going from the top to the bottom. So basically, except for one little thing I would add in here, in an undisturbed rock layer, you may want to jot something like this down. The one thing that you want to add is, and this is going to kind of come into question number 3 up there. In an undisturbed rock layers, the oldest rock layers are where? Bottom, and the youngest rock layers are on top. Okay. Now, that kind of threw in the last question. What can cause layers to change from horizontal?
New plates.
What's that?
New plates like that just come in and weird everything.
Yes. Okay.
Weathering, volcanoes, and sedimentary rocks.
Yep. So, and basically, this all ties in back to where our concept is, because you both gave examples about the rock cycle can manipulate and disturb rock layers, and especially the big one that Angel did is plate tectonics. Because that's going to cause rock layers to be undisturbed. So here's just sort of a real quick local example. See if I can get my, oh, come on, I had a Promethean pen working last hour and it quit. Oh, it's asleep, hold on. Flashing, okay, is it gonna work? Yes, yay. All right, so if we think about, if you look up at White Mountain when it's not covered in snow, White Mountain is pretty much made up almost entirely of sedimentary rock layers. Where's the oldest rock layers gonna be?
On the bottom.
Yeah. So if like, say this is the school, and we're sitting out here where we can see White Mountain from where we're at. So if we were to take a walk from the school, end up to White Mountain, and then climbed up the side of White Mountain up to the top where we can see Pilot Butte, you can see those different individual sedimentary rock layers. Now, where's your, in this picture so far, where's our oldest rocks?
On the bottom.
Yeah, our oldest ones would probably be right here, probably are, and our youngest are right there. But these rocks are not up on White Mountain, are not sitting horizontal. Matter of fact, if we did take off walking from the junior high heading out to White Mountain, would we be starting off with our oldest rocks?
No, wouldn't we start off with the youngest?
Yes.
Because it's on a vertical.
So
Not vertical.
we're standing on sedimentary rocks here in Rock Springs. So do these rock layers all match up with each other?
No.
Not today they don't. Did they at one time possibly?
Yeah.
Yes.
Yeah, because there is an old ancient fault right here at the base of White Mountain. And it kind of goes down this way, and it was because this would have been referred to as a reverse faulting activity, where there was pressure being put on the state of Wyoming, thanks to plate tectonics. Don't want to step into somebody's, natural resource research project. But yeah, this rock, you would be starting off in our young rocks here. And the rocks that we are standing on here in Rock Springs, for the most part, are gonna be about the same age here as these rocks that are making up the top of White Mountain. Because at one time, it used to be down here matched up. So faulting, and so now we've got these ones are horizontal, thanks to plate tectonic activities. These ones are now out of horizontal. So there's kind of an easy example.